Welcome to all of you. Today we discuss about a simple list of simple uh, formulas of Laplace transform, paper DSC B1 Advanced Calculus, BSc General Mathematics. This is a list of simple formulas for Laplace transform. This L of capital Ft is equal to small fs is equal to integration 0 to infinity d to the power minus st capital F dt t greater than 0. L of 1 equal to 1 by s is greater than 0. L of t 1 by s square is greater than 0. L of t to the power n factorial n by s to the power n plus 1 n equal to 0, 1, 2, 3 are all integers, positive integers here with including 0. L of e to the power at here a is constant 1 by s minus a is greater than a, that is you may write L of e to the power minus at is equal to 1 by s plus a. L of sin at equal to a by a square plus a square is greater than 0. L of cos at is by a square plus a square is greater than 0. L of sin hyperbolic at a by a square minus a square is greater than mod of a. L of cos hyperbolic at equal to s by a square minus a square is greater than mod of modulus of a. L of t to the power a is greater than minus 1, gamma a plus 1 by s to the power a plus 1 is the gamma function. Here we give some properties of Laplace transform. Linearity property L of C1 capital F1t plus C2 capital F2t is equal to C1 L of F1t plus C2 capital F2t. First translation property or first shifting property L of e to the power at capital F equal to f of s minus a. Second translation property or second shifting property L of capital GT equal to e to the power minus as small fs, where capital GT is the capital F bracket t minus a t greater than a and 0 when t less than a. Change of scale property L of capital F at is equal to 1 by a small f of s by a. Laplace transform of derivatives L of capital F dash t equal to s small fs minus capital F0. L of capital F double dash t is equal to a square fs minus s capital F0 minus f dash 0. L of f triple dash t is equal to s cube small fs minus s square capital F0 minus s capital F dash 0 minus capital F double dash 0. Laplace transform of integrals L of integration 0 to t capital F u du is equal to small f of s by s. Multiplication by t to the power n. Laplace transform t to the power n ft is equal to minus 1 to the power n nth derivative with respect to s dn ds n fs small fs is equal to minus 1 to the power n small f nth derivative of s. Division by t L of ft by t equal to integration s infinity. Actually, this is the integration s to integration s to infinity f of u small f of u du. Using first shifting property, this is the first shifting property is this L of e to the power at ft equal to small f of s minus a. Using the first shifting property, we can again list of simple properties. L of e to the power bt sin at is a by s minus b whole square plus a square. L of e to the power bt is cos at equal to s minus b whole square plus a square. E to the power bt sin hyperbolic at equal to a by s minus b square minus a square. E to the power bt cos hyperbolic at Laplace transform of this s minus b whole divided by s minus b whole square minus a square. Laplace transform of t to the power n e to the power at is equal to factorial n by s minus a whole to the power n plus 1. Using the second shifting property, that is the second shifting property is this: L of gt equal to e to the power minus a small fs, where gt is equal to f of t minus a t greater than a. Using second shifting property, we get L of t minus a whole to the power n, that is equal to e to the power minus s n factorial by s to the power n plus 1, n equal to 0, 1, 2, 3, dot, 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 t greater than a. L of sin a t minus b is equal to e to the power minus bs into a by s square plus a square t greater than b. Inverse Laplace transform L inverse small fs is equal to capital F t. So L inverse 1 by s equal to 1, L inverse 1 by s square equal to t, L inverse 1 by s to the power n plus 1 equal to t to the power n by n factorial, L inverse 1 by s minus a equal to e to the power at, and L inverse 1 by s plus a equal to e to the power minus at. L inverse 1 by s square plus s square equal to sin at by a. That is L inverse a by s square plus s square equal to sin at. L inverse s by s square plus s square equal to cos at. L inverse 1 whole divided by s square minus s square equal to hyperbolic sin at by a. L inverse s whole divided by s square minus s square equal to hyperbolic cos at. And properties: linearity property, L inverse C1 small f s1 plus C2 small f s2 equal to C1 L inverse f1 s1 C2 L inverse f2 s2. First translation of first shifting property, L inverse f of s minus a equal to e to the power at into capital Ft. Second shifting property, this is the L inverse e to the power minus a small fs equal to f of t minus a t greater than a, 0 when t less than a. Change of scale property, L inverse f of k is equal to 1 by k capital F of t by k. Inverse Laplace transform of derivatives, L inverse nth derivative with respect to s, small fs is equal to minus 1 to the power n t to the power n capital Ft. Inverse Laplace transform of integrals, L inverse integration s to infinity f u du equal to capital Ft by t. Multiplication by s, L inverse s small fs equal to capital F dash t. Division by s, L inverse fs small fs by s equal to integration 0 to t capital F u du. The convolution property, L inverse small fs gs is equal to 0 to t capital F u capital gt minus u du is equal to capital F star g. This star is the operator, and this is meaning of this star F capital F star capital G. This means this integration 0 to t capital F u of capital G u t minus u du. Using first shifting property of this inverse Laplace transform, L inverse 1 by s minus b whole square plus s square equal to e to the power bt sin at by a. L inverse s minus b by whole divided by s minus b square whole square plus s square equal to e to the power bt cos at. L inverse 1 by s minus b whole square minus s square equal to e to the power bt hyperbolic sin at by a. Inverse Laplace transform of s minus b whole divided by s minus b whole square minus s square equal to e to the power bt hyperbolic cos at. Inverse Laplace transform of 1 by s minus b whole to the power n plus 1 equal to e to the power bt e to the power n by n factorial n equal to 0, 1, 2, 3, 4, dot, dot. Using second shifting property, A inverse e to the power minus as factorial n by s n plus 1 is equal to t minus a whole to the power n t greater than a. This is the second shifting property. This is the second shifting property, and this is the first shifting property. L inverse e to the power minus b is a by a square plus a square equal to sine of a into t minus b t greater than p. Now we use partial fraction technique to solve the inverse of Laplace transform. So partial fraction technique is this: px plus q whole divided by x minus a into x minus b, a not equal to b. In the denominator, we have two linear factors, and then this equal to partial fractions. This is the a capital A by x minus a plus capital B by x minus b, and this capital A and capital B are to be determined from this px plus q. Px plus q whole divided by x minus a whole square. Linear factor, the quadratic square, so power is 2. So linear factor, power of linear factor is a by x minus a plus b by x minus a whole square. Px square plus qx plus r. There are three linear factors in the denominator. So a by x minus a plus b by x minus b plus c by x minus c. Px square qx plus r, x minus a whole square x minus b. So a by capital A by x minus a plus capital B by x minus a whole square plus capital C by x minus b. Px square plus qx plus r, x minus a, the linear factor with the quadratic factor x square plus bx plus c. Then for linear factor we write a by x minus a plus b capital Bx plus c by x square plus bx plus c. So this bx plus c is for this quadratic factor x square plus bx plus c. Now you can consult this book, a very important book for students. Sam's outline series, the Laplace transform, Spiral. This is the only theory and problems for Laplace transform. All these PDF of this book and this note are given in the description box for your helping. This is Laplace transform, inverse Laplace transform, and these are the details. You can check it, or details list of the formulas here, and this piecewise function, exponential order, and so on. This linearity property and proof of this linearity property. An example, a theorem first transition property is this example, and this scale property, scale change property, derivatives, and integral, multiplication by t to the power n, division by t, and periodic function. And for this formula and details of get this, and first study this uh, theory for our mathematics general course in semester 6. Thank you for watching this video.